We're back after a long weekend, ready for a whole lot of math. And good news for everybody out there, Algebra 1 students, Pre-Algebra students. Today's lesson is for both of you. Because today we're going to be talking about our rules of exponents. It's going to be awesome. But before we get to that, what do we have to do? Of course, we got to open up some fun stuff. We have to take some Disney pins, look at some quotes of the day. We'll get to the math in just a second. First off, our pins for today. We've got Fantasia Mickey and low-key one of my favorite Disney movies, Robin Hood. And come on, how can you not enjoy the classic Robin Hood? Personal favorite pins. What else we gotta open something up, of course. Today, we got a little Avengers Zoom Zoom. Let's see what we get. Oh yes. Oh yeah, that's right. The true MVP of the Guardians of the Galaxy. It's Groot. I am Groot. Maybe I could do this whole video in Groot voice. I am Groot, I am Groot. I am Groot. No, that probably wouldn't work too well. There might be a little bit of confusion. Groot can just sit up there. Of course, quotes of the day. This past Friday we didn't have a video because it was Good Friday. Sorry about last week's video coming out a little bit later, but the Friday quote of the day was a good one. Let's all take a moment and be thankful that spiders don't fly. That's just truth. Today's quote of the day, fresh off the page. My body type is like, you can sort of tell I work out, but you can also tell that I don't say no when someone offers me dessert. That's just sad. We're going to sit up here and make me feel bad. Quote of the day. We've done our quote. We've opened something up. We've done our pins. It's time to go to the board. It's time to get to the math. Okay, now, Dwight, Pam, Jim, no fighting, no pranks. Pay attention. This will be on the quiz. All right, everybody, we're back, ready for our lesson on the properties of exponents. We're going to group these together into ones that are kind of similar, kind of work together. We're going to start with two that are up here. We have the zero exponent property and the negative exponent property. Now, our zero exponent property says any non-zero number raised to the 0th power equals 1. It's a pretty simple rule. And our negative exponent property says if we have a number raised to a negative exponential power, we can simplify that by rewriting this as 1 divided by the same number raised to the opposite exponent. Now that's great. That's all algebra and letters and stuff. It makes more sense with numbers, I think. I'm pretty sure most of y'all do too. So let's start here. 3 to the 1st power. Any number raised to the 1st power is just itself. So 3 to the 1st power equals 3. Great, great. So we're going to work to the left, then we're going to go to the right in just a second. We know 3 to the 1st power is 3. 3 squared. That's right. 3 squared is 9. And 3 to the 3rd power is 27. Every time our exponent increases by 1, we're really just multiplying the previous value by 3. 3 to the 1st power is 3. 3 squared is 3 times 3. 3 to the 3rd power, 3 times 3 times 3. So as we work, as we add values to our exponent, we're multiplying the previous value by 3. But if I work to the right, instead of thinking about increasing a value, we can do a decreasing value. From 3 to the 3rd power to 3 squared, when we subtract 1 from the exponent, we're dividing the previous value by 3. From 3 squared to 3 to the 1st power, dividing by 3. So if we follow that same pattern, remember algebra is all about these patterns, these wonderful things. We're going to do the same process, which means if I subtract 1 from the exponent again, I should just be dividing by 3. And 3 divided by 3, or any number divided by itself, equals 1. Now, if that worked with positive exponents, that same rule, same pattern should work as we get into negative values. So if I go from 3 to the 0th power to 3 to the 1st power, we divided by 3 here, divided by 3, divided by 3, we should just keep doing the same thing. 1 divided by 3 is just 1/3. From 3 to the negative 1st power, 3 to the negative 2nd power, again. We're subtracting 1 from the exponent, so we divide by 3 again. Get 1/9. That's why when we talk about negative exponents, we're not talking about negative values or our base becoming a negative number. We're just representing it with an exponent and seeing a way to algebraically produce a number. Got a couple more rules coming right up. Just a second.
2,000 years later.
Okay, so we just did our 0 exponent property and our negative exponent property. What we're going to move into now is the product rule and the quotient rule. Now, both these rules have very similar premise. We have to be talking about either multiplying or dividing with two numbers that have the same base and exponents. So in this case, our product rule is if I've got x to the a power times x to the b power, which means I have the same base and exponents, all we have to do to simplify this is add the exponents together. So for an example, if I've got 4 to the 3rd power times 4 squared. When we say 4 to the 3rd power, what we're really saying is 4 times 4 times 4. I could rewrite that as 4 times 4 times 4. And 4 squared is just 4 times 4. How many 4s are being multiplied together in all? 1, 2, 3, 4, 5. We got 4 to the 5th power. So all we have to do is add those exponents together. We're able to apply the product rule. Again, we're going to use our algebra brains here and use our logical thinking. Product refers to multiplication. We multiplied two numbers that have the same base and exponents together. We added the exponents. Now we're going to talk about the quotient rule. We're dividing two terms that have the same base and exponents. What should we do with those exponents? Yeah, we're going to do the opposite action. We're going to subtract. If we added for our product rule, it would make sense to do the opposite for the quotient rule. So we will subtract our exponents. So x to the a power divided by x to the b power equals x to the a minus b power. Again, letters are great. You know what a lot of people understand better? Numbers. So let's go over here. We use our same values here. Now 4 to the 3rd power divided by 4 squared. We just said 4 to the 3rd power is really just saying 4 times 4 times 4. We're dividing that by 4 squared, which is 4 times 4. We know if I'm dividing any number by itself, that's equal to 1. So really, 4 divided by 4 is 1. 4 divided by 4 is 1. What does that leave me with? 4 to the 1st power, and coincidentally, 3 minus 2 equals 1. See, again, these rules are so simple. As long as we use them correctly and pay attention to little details, it makes life a whole lot easier, especially when it comes to simplifying expressions, which we'll get to a little bit later on. We've got 4 rules down. We've got 2 more to go. Be back in a second. All right, we're here, ready to go for properties number 5 and 6 for our exponents. So, number 5, power of a power. Power of a power. All it means is we're raising a number, raising our base to an exponential power, and then raising that to another power. So for example, x to the a power raised to the b power, all we have to do to simplify this down is somebody's using my pens, my markers, and not putting the caps on correctly. You've got to know dry erase markers will dry out. It's in the name. No, it's all good. USA. Well, we're good. We're fine. Which color? We'll use this. We'll use pink for this then. Power over power. X to the a power raised to the b power. Well, all we have to do with our exponents here is multiply them. Yeah, let's put this to work. 4 squared to the 4th power. When we're raising something to an exponential power, all we're doing is multiplying the base times itself this many times. So in this case, look, what we're saying is this is 4 squared being multiplied together 4 times. 4 squared times 4 squared times 4 squared times 4 squared. We just did this property. This is just our product property, right? This same base being multiplied together. All we have to do is add our exponents. 2 plus 2 plus 2 plus 2 is 4. It's the 8th power, and again, 2 times 4 equals 8. Wow. It's always nice when the math works out nicely. That's our power of a power rule. Our final rule is power of a product or a quotient. Right? So not just saying that we've got the base being one number, one term, raised to a power, but now we're raising a product or a quotient to an exponential power. So it should be like, for our product, xy raised to the a power. The product of x and y raised to the a power. We're going to get to use a property that has been featured heavily in the first, every episode we've done so far. It's the old distributive property with exponents. Because what we're saying is we're multiplying, or this entire product is being raised to the a power. Well, that's really just saying x to the a power times y to the a power. Nice and simple. And for a quotient, and quotient's just division, if I've got x divided by y to the a power, we can actually simplify this down by saying that's the same as x to the a power divided by y to the a power. Pretty easy, right? Those are 6 rules. So we're going to do a practice problem or 2 here in just a second. Then the pre-algebra approach will be done. The algebra video will continue a little bit longer because we're going to do a little bit with some rational exponents. And then we'll be done for the day. We'll see you back in a second. An extra break right now. Family, again. Guys, we've been doing these videos now for a week and a half. Every day, coming and supporting the family, coming and supporting me, teaching it. Hey, Wolverine, Teen Wolf, Mufasa, you're going to have to move. Get out of the way of the siblings. They got to see the board. Anthony, Ross, Elmo, Becca, Nelson, thank you all again for coming, for being a part of this. Getting to hang out with King Griffey Jr. today on the side with you. I feel like it's a big a bump in your social level. And thank y'all so much. I bet we see them tomorrow. I bet it happens. All right, so hopefully you've been taking some notes on what we've been doing, because somebody just wrote a whole bunch of letters and numbers and weird formations on my board. I guess it's not weird. It's just a problem for us to simplify. But there's a lot going on in these questions. There's a lot happening. So real quick, if you haven't already, pause this video in like 10 seconds. Write down all of our exponent rules real quick. Just something like this right here, just to remind us what they look like. To remember that if I'm looking at a product property, the result should be the base raised to 1 exponential power. That's the sum of the exponents. If I see something like this, a power to a power, it should look like this in the problem, and this is our result. Real quick, pause. I'll wait. I'm going to wait just in case. Maybe you can't find the pause button. Maybe you were trying to find the pause button, and instead of hitting the pause button, you accidentally exited out of this video and had to restart. I don't know. All right, if you haven't finished yet, now definitely pause the video because it's time to move on. We're going to simplify these expressions using our exponent property. So let's start right over here. we've got the product of 4ab to the negative fifth power, all raised to the negative second power. Just think, well, which of our rules do we see? Well, like b has a negative exponent. That's something we talked about today. And I've got a product being raised to a power. Almost like a power of a product. If you remember, for a power product, all we're doing is distributing our exponent using our distributive property to each term, or each value, as being multiplied together. So really, this is saying 4 to the negative second power times a to the negative second power times b to the negative fifth power to the negative second power. Now, is that simplified? Well, no, because I still see some math that looks a lot like some of our property rules. I was like, which one's first? Well, 4 to the negative second power, we know if we have a negative exponent, we simplify that by rewriting the term as 1 divided by 4 to the opposite power, so 1 over 4 squared. We could do the same with a to the negative second power. We could go ahead and do that with b to the negative fifth power, but I see another property we can be working with here. I think if we work with our power of a power, we can avoid doing a little bit of extra work. Because if I've got b to the negative fifth power raised to the negative second power, all we do is multiply those exponents together. Negative 5 times negative 2, positive 10. Now we just multiply these together. Well, if I've got a fraction here being multiplied times a fraction times or b to the 10th power, we can simplify that down. It's b to the 10th power over, well, 4 squared is just 16, a squared. That'd be our simplified expression here. Now, if you go from the beginning, look at where we ended up, it might seem overwhelming. But don't forget, our goal was to find one thing we can do at a time. And if you're not sure, try something. If you're not sure what we're supposed to do first here, we know the rules, try one. See if it works, see if it fits. If it doesn't, go back, try again. That's the beauty of math, is if we work through mistakes, work through getting questions right or getting questions wrong, we're able to understand the material better. All right, our second problem here. 4x to the third power y squared times 3x to the sixth power y to the third power, all divided by 24x to the 11th power y squared. So there's a lot happening in that expression. If we try to do it all at one time, it's probably going to get a little confusing. It's probably going to end up with the math errors somewhere along the way. So let's just start with the numerator. Just the numerator at the top of our fraction. All we have is 6 things being multiplied here, right? This is 4 times x to the third power times y squared times 3 times x to the sixth power times y to the third power. Thinking about this as a fraction, in the numerator, we can multiply the like terms here together. 4 times 3 gives me 12. Thanks to our product rule, we know that x to the third power times x to the sixth power, we can simplify that down or rewrite it as x to the 3 plus 6 power, which is 9. Y squared times y to the third power, y to the fifth, and my denominator will stay with 24. X to the 11th power, y squared. Now, we've simplified a little bit now, but are we completely simplified? Is there anything else we can do to simplify the expression down? I see something right here, a quotient property. I could think about this really as 12 over 24 times x to the 9th power over x to the 11th power times y to the 5th power divided by y squared. Fix that 11 just a little bit. all I did is rewrite this expression in an equivalent form, but in a way it's going to help us simplify this easier. Because we can divide 12 by 24. You know that just equals 1/2. X to the 9th power divided by x to the 11th power. Our quotient property says if we have the same base and exponents, we subtract those exponents. So 9 minus 11 will be x to the negative 2nd power. Y to the 5th power divided by y squared. 5 minus 2 is 3. We're almost done. If we can rewrite this expression down, I've got x to the negative 2nd power. I see that negative exponent, so we don't want to forget to make sure that goes into the denominator of this fraction. We've got y to the 3rd power, our positive exponent, over 2x squared. That looks a lot easier, a lot simpler than what we started with, doesn't it? The key, guys, when it comes to trying to break these things down, whether it's just numerical values that we're seeing, whether we have variables involved, one step at a time. Don't try to do the whole problem at once. We want to make sure one thing at a time as we work down our process until we can't do anything else. All right. Pre-algebra, guys, you're going to be done. Algebra, guys, hang on for just a second. We're going to do a little bit more, and we'll expand on that stuff tomorrow. So be back in a second.
6.5 hours later.
All right, that's it. We've done, what, nice little chunk of math. Not too long, didn't kill your day, but hopefully everybody's a little bit smarter, doing a little bit better with the material, doing your algebra for life. Right. See, I'm making jokes all the time. I'm just kidding. Guys, hashtag son of the teacher of the universe is killing it. Y'all are killing it. Again, we're going to be doing some more review topics this week. If you know of one, if you think, you know what? Man, I remember the second 9 weeks, life was awful, and I wanted to punch myself in the face every day because of this one thing we were working on that I couldn't get. And you want us to go over it in one of these lessons? All you gotta do is send me an email real quick. Just real fast, say, hey, Mr. Jerkins, remember that month where I cried every day? And I'll be like, oh yeah, I totally remember making fun of you. I'm just kidding, I wasn't making fun of you. But I'll totally remember when we struggled with this, or when some people had issues here. We'll go over those topics again. Otherwise, I'll pick the topics, which are the ones I want to do. Like today's topic on exponents. That's it for today. We're done. We'll see you tomorrow. Have a great day.